All right, let's get started. Are there any questions on the material so far? Okay, so in this set of lectures, these three and then the fourth one on social capital, I'm going to be talking a lot about real-life social networks and not so much the online variety, though I have things to say about that as well. And these kinds of networks are the face-to-face networks that we human beings have been making for tens of thousands of years, ever since we emerged onto the African savanna. And in fact, I'm deeply interested in what I would regard to be the fundamental origins of human sociality. Why do we make these networks, and what do they mean for our lives? They are, in my judgment, the kind of human equivalent of ant colonies. And I'm going to be talking to you about how we can use social networks and our insight into them to make the world a better place. So given an increasing understanding of the structure and function of human social networks, how can we use that knowledge to intervene in the world to improve public health, economic development, security, and other aspects of our collective and individual well-being? And I'll be talking about that, I think, in 2 lectures from now. So first of all, this interest of mine in networks began about 15 years ago, and at the time I was a hospice doctor taking care of terminally ill patients in the south side of Chicago. And about every Saturday afternoon, typically, I would take my little black bag and I would go on home visits, visiting people who were dying. And oftentimes, I would, in the course of caring for them, I would not surprisingly come to know their families. And I began to observe how illness and death in the person that was dying affected not just themselves, but also their loved ones, those people around them. And in my lab at the time, I was studying the widowhood effect, which we discussed last time and which is also featured in Connected. And the widowhood effect, as you all know, is dying of a broken heart. So it's the increased probability of the recently bereaved to die, and there's been a raft of literature on this going back 150 years. And I consider this to be one of the canonical findings in the social sciences. And one of the things I like so much about this finding is that it's all about our connection. It's about how something that happens to us affects other human beings to whom we're connected in what you might even think of as a very distinctively human way, although there's interesting work on certain animals who grieve and how they suffer from the death of their loved ones as well. So here's an example of a couple, for example. This man is dying of a brain tumor, and here's his very loving wife that's sitting with him. One day, however, I was taking care of a woman when I was back in Chicago, 15 years or so ago now, who was dying of dementia, and her mind was basically gone, this woman, and she had been sort of in a fetal position now for a year or two. She was dying at home, and she was being cared for by her daughter. And the daughter, the adult daughter of this elderly woman, was completely exhausted from the necessity and the endlessness of caring for her mother. And her husband, the daughter's husband, had become sick as a result of his wife's exhaustion. And one day as I was leaving this home, having cared for this family that afternoon, my big bulky cell phone, not like the cool ones we have now, my big bulky cell phone rings, and it's the best friend of the husband who had become depressed by what was happening in his friend. And I suddenly had 2 very obvious ideas to me. Here's this random guy calling me out of concern for what was happening to his friend. And I suddenly realized that the widowhood effect was not just restricted to husbands and wives, but could also affect other sorts of social dyads. And it wasn't even restricted to dyads. It could spread more broadly within social systems. Here we had a kind of a non-biological transmission of disease from the woman to her daughter, from the daughter to her husband, from the husband to his friend, to 4 degrees of separation, from one person to the next, to the next, to the next, cascading through this kind of network. So I began to think about the non-biological spread of physical and mental illness about 12 years or so ago. And I came to see the world in what was, for me, a whole new way. So here's the mother-daughter pair, this couple of individuals. And here's what happens when we add the chain of 4 individuals and other pairs of individuals nearby. And here's what happens when we add still more people, because all these people are connected to each other via ties of marriage and friendship and work and family. And I realized that pairs of people and the effect that they had each other, and this widowhood effect, which I had been studying, was actually a special case of a much broader social phenomenon, not restricted to death, not restricted to husbands and wives, but rather more generalizable in a variety of ways. And these connections that we embed ourselves in are truly vast. And I became obsessed with this topic. I became obsessed with understanding why we humans do this. These things, to me, strike me as intricate things of beauty. And these networks that we make are so elaborate and so complex and so ubiquitous, in fact, that we have to wonder, what purpose do they serve? I mean, why are we embedded in networks? How do networks form? How do they work? And how do they affect us? And so I'm going to be spending the next 3 lectures telling you, or summarizing for you, what I've come to learn about human social networks over the last 10 years of my life. So first of all, what's the difference between a group and a network? Here's a group of people, 100 people, every dot is a person, and a group of people might be referred to like those people over there waiting in line to get into a concert, for example. Or a group might be a group defined by a category, like Democrats or Republicans or Buddhists, say over there, or scuba divers. That's a group of people. But the difference between a network and a group is that a network, in addition to the constituent individuals, also has ties. There's something extra in a system that is a network. In addition to the people, there are the connections between the people, a specific number of connections and a specific pattern of connections. And there are 2 broad categories of networks. There are artificial networks and natural networks. And the simplest sort of artificial network we could imagine would be a bucket brigade. So we take these 100 people and we arrange them into a form of a simple linear network. Every person take these 100 people and we add 99 ties. Every person is connected to the person on the left and the person on the right. And by adding these 99 ties, we give this group of people properties it did not previously have. It's now more able to, for example, put out a fire in the form of a bucket brigade, or efficiently transport debris out of a big crater. So adding these 99 ties to these constituent individuals confers upon them additional properties that weren't present before we arrayed the human beings into this particular kind of network. But one of the key and interesting ideas about networks is that how you arrange the ties can affect the property of groups. For example, you could take the same people and the same number of ties and arrange them into the form of a telephone tree. This is an old-fashioned technology before the invention of the internet. If there was like a school closing and you wanted to notify all the parents that the school was closed, the person in the middle, indicated by the white arrow, would have 2 people they were supposed to call. The principal would call that person, say, school is closed. That person would call 2 people. Each of those people had a call list of 2 additional people, and the information would spread rapidly through this call list of people in the system. So this network arrangement, same number of people, same number of ties, is optimized for the efficient, rapid, and accurate transmission of information. This type of archetypical or canonical structure, however, also can be used in other sort of social things that we see. For example, the same thing is at the root of Ponzi schemes. But now, instead of information starting into the middle and spreading out to the periphery, in a Ponzi scheme, money starts in the periphery and spreads in towards the middle. Or we could take the same number of people, 100 people, and a different number of ties, and organize them this way into the form of military squads. So we take a company of 100 men or women, each of them is organized into squads of 10. We've got 10 squads of 10 men, and within each squad, everyone knows each other extremely well, a very dense, interconnected set of ties. And this arrangement is able to call forth from these individuals something that wasn't necessarily present before, something extraordinary, namely a willingness literally to die for each other. Before you arrange them in this way, if they had been merely a group, an amorphous group, these people wouldn't be willing to kill themselves for each other or die for each other. And yet when you arrange them in this way and cultivate a particular set of ties, you're able to call forth from the constituent individuals properties that didn't exist before. Or you could begin to understand how real social networks differ completely from artificial social networks. Here, for example, is what a real network looks like. And it differs in shape and in appearance, and typically also in size compared to artificial networks. Here's what a natural network looks like. So we began to study natural social networks in my lab in 2002. And this is one of the first images that we made from one of our first studies. And this image began to help us to understand the role of social networks in obesity. And when we began this work over 10 years ago, it had become very fashionable to speak of obesity as being an epidemic. But my colleague James Fowler and I wondered whether obesity really was epidemic. So it was clear that obesity was epidemic in one meaning of the word, which is that there's more obesity than there used to be before. And we have already seen in the class that obesity has risen from about 20% to 30% of Americans being obese just in the last 10 years, and fully 2/3 of Americans are now obese or overweight. But we wondered whether we could understand obesity as being literally epidemic, not just metaphorically epidemic. Could we find evidence for a kind of social contagion whereby weight gain in one person could spread and cause weight gain in other people to whom that first person was connected? So this is 2,200 people drawn from the Framingham Heart Study. We were able to use that data in a kind of serendipitous way. I had gone there to talk to the Framingham Heart Study about collaborating with them on something and stumbled on the existence of these paper records, which had not previously been used for research purposes. And we realized that if we computerize these records, which took about 2 years of our life to do, if we computerize those records, we could reconstruct the social networks of the Framingham Heart Study. So every dot is a person. Every line between them represents some kind of a relationship, who's sibling, spouse, friend, coworker, neighbor, and so forth. And we make the dot size proportional to people's body mass index. So bigger dots are bigger people. And we also color the dots yellow if people's body mass index is above 30. So if they're properly obese, we colored them yellow as well. And if you look at this image, you might be able to see evidence for some clustering of obese and non-obese individuals within the network. So maybe there's a cluster here, and a cluster of non-obese individuals here, and another cluster of obese individuals there, for example. But the visual complexity, perhaps consistent with little outbreaks of obesity. But the visual complexity of this image is still very high. And in any case, several questions are raised by this clustering. First of all, how much clustering is there? Maybe there's just, we need some way of quantifying the extent of clustering. Second, is there more clustering than simply due to chance? Maybe it's just dumb luck that there's some clustering. Third, how big are the clusters? What's the radius of the clusters? And fourth, most interestingly, what might be some causes of the clusters? So we borrowed some ideas from statistical physics, and one idea is, and we did what is known as a topological permutation test. So let me just walk you through how this works, because it sort of sets an intuition for how we might go about using mathematical tools to discern the existence of clusters within networks. So imagine that we have a sort of a cartoon-type network, and that the 40% of the people in the system are obese, and they're randomly and uniformly distributed through the population. So the yellow dots are the obese dots, and the red dots are the non-obese. So here we pick an obese person in the system, and we go to 1 degree of separation, and let's say there are 5 people that are obese in that 1 degree of separation from that person, and we find that 40% of the 5, 2 of them are obese. Then we go to 2 degrees of separation, and let's say there are 15% of people in that shell of the onion. In expectation, in a randomly distributed network, 6 of them would be obese, 40%. And we go to 3 degrees of separation, we have, let's say, 25 people in that shell of the onion. In expectation, 10 of them, or 40%, would be obese. So in a system in which people are kind of smoothly and randomly distributed with the trait of interest in the network, any degree of separation from an index case, in expectation, on average, the index amount, 40% or whatever it is, would be obese. On the other hand, if BMI was clustered, we would see something different. So here, for example, we would see an obese individual. We might find 3 of 5, or 60% are obese at 1 degree of separation, 7 of 15, or let's say 50% at 2 degrees of separation, and 8 of 25 when we get to 3 degrees of separation. It would be as if you imagine this vast fabric of humanity that social networks might be. I'm connected to you, and you to her, and she to him, on out endlessly into the distance. It would be as if you deformed this fabric and made these peaks and valleys within this fabric, so that there were individuals that were at the top, let's say, that were obese, and as you fell away from them into the valleys, you would get the non-obese individuals, and you would come back up again, kind of reshaping, not quite, but sort of reshaping this fabric so that you had these kind of peaks and valleys in the attribute of interest within the system. And if you begin to think about it this way, what you can do is you can take the network, you can fix its topology, you say, okay, here's the structure of the network, you observe 40% of the people are obese, and then you randomly highlight at random 40% of the nodes as being obese, and you can create what's known as a sampling distribution, can look at how likely is the network that I actually observe with a clustering to have been created just by a chance process. And when you do all of that rigmarole, all of that mathematics, you're able to decide, gee, is the clustering that I see in the network more than could simply have been due to chance alone? And when you do all of that, you get some results that look something kind of like this. On the y-axis is the increase in the probability that a person is obese, given that a social contact of theirs is obese. And on the x-axis is the degrees of separation between the two people. And so what this says on the far left in the purple bar is that if your friends are obese at 1 degree of separation, you have a 45% higher likelihood of being obese yourself. And if your friends' friends at 2 degrees of separation are obese, you've got a 25% higher likelihood of being obese. And if your friends' friends' friends at 3 degrees of separation are obese, you've got a 10% higher likelihood of being obese. And it's only when I get to your friends' 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 friends at 4 degrees of separation that there's no longer an association between that person's body size and your body size. So if I knew nothing else about you, then the body size of these individuals who are almost certainly strangers to you, your friends' friends' friends, for example, I would be better than chance able to predict your body size. There's some association between your body size, something so seemingly individualistic and deeply personal, and the body size of these individuals who are total strangers to you, removed within the network at some degrees of separation. So this type of analysis tells us 2 things. First, there's more clustering than due to chance. If it were chance, it would be 0% across the board here. And second, that these clusters spread to 3 degrees of separation. There's an association between your body size and people that are up to 3 degrees removed from you. But it doesn't tell us what might be the cause of the clusters. And there are at least 3 possible explanations for why we might find such clustering in a social system. One possibility is a kind of social domino effect or induction. Here the idea is that as I gain weight, it makes Lucy gain weight. As Lucy gains weight, it makes you gain weight. As you gain weight, it makes her gain weight. And there's a kind of spreading process within the network, a kind of causal effect of my weight gain upon these other individuals, like a germ spreading from person to person. A second possibility is it's not that my weight gain causes Lucy's weight gain, rather it's that Lucy and I form a relationship because we have a similar body size to begin with. I wish. Or that we had a similar interest in exercising or eating behaviors that causes us to form a union, and that's why we have a similar body size. That's known as homophily, or birds of a feather flock together, or love of like, homophily. A third possibility is that it's not that my weight gain causes Lucy's weight gain, nor that Lucy and I form a union because we have a similar body size, but rather that Lucy and I share a joint exposure to something else, like a gym that makes us both lose weight, or a fast food joint that makes us both gain weight at the same time. Now, typically, all 3 of these phenomena, induction, homophily, and context, or confounding, are present in any kind of social process. And it takes a variety of strategies, both observational, econometric strategies, and experimental strategies to tease these apart. And you can begin to see these things occurring in all kinds of things in the world around you. For example, here's a dorm room from Kirkland House that belongs to the roommate of a student I know very well in that house. So if you look at this dorm room, you can see that it's kind of a disaster. And this is a both-angle shot from both sides. So the question is, what's going on here? Did one roommate's lack of tidiness affect the other roommate? Did one roommate cause the other to become a slob? Did they decide to be roommates because they both shared similar standards, low standards of cleanliness? Or was there some exogenous event that caused them both to act in this ridiculous way, such as the small rooms at Kirkland House, or the lax standards of Verena and Tom Conley that permit this kind of behavior to happen? So all 3 of these things are possible, and you can begin to imagine that this occurs with any kind of social behavior. For example, GPA. Do studious students cause their friends to become more studious? Do studious students preferentially form attachments to other studious students? Or do both studious students share an exposure to a charismatic or particularly good professor that makes them both become studious at the same time? Now, in this particular case, however, one of the things that was concerning was that this was not a temporary state of affairs in this dorm room. So here we are 2 weeks later. The beds have clearly been slept in. These books have not been moved in the last 2 weeks. But it looks like this was some kind of suntan lotion that's been replaced by water. So we understand the priorities of these students in this particular room. So actually, but this sort of this depiction of the lack of change across time in the rooms sets the stage for beginning to understand how you can begin to study networks and these effects longitudinally across time. and actually begins to shed some light on how you can understand how these processes might spread within networks. Because in fact, in the Framingham Heart Study, the longitudinality of our data was extremely helpful in tracing out the cause and effect, or the issue of homophily versus induction. So I'm about to show you a little 30-second video animation that took 5 years of my life and $1 million to make. And my kids joke that on a per-second basis, it's more expensive than Avatar and much less interesting, and they're right. So this little video is real data. It's real data. And when we began this project, we had in our mind a kind of ideas borrowed from many physics experiments that you guys did when you were in high school. You may remember that water table experiment where you had a still water table and you set up an apparatus and drop a marble onto the surface. And by doing various sorts of manipulations, if you drop the marble just right, you can get a wave to form on the table. And when it hits the perimeter, it'll bounce back and you'll get a standing wave on the surface of the water. Or if you don't remember that experiment, you'll remember when you were little kids. Do you remember that feeling of sloshing around in the bathtub? And if you slosh around just right, you make a big wave that'll come out of the tub and make a big mess on the floor? That's you've made a standing wave on the surface of the water, and that's what's causing it to happen. Now, what we were interested in is to see whether we could discern evidence for waves of obesity within this social surface. Social networks can be thought of as a hyperdimensional surface, as a kind of sociotopological surface. So our question was, if I gain weight and makes my friends gain weight, can we actually visualize these waves of obesity spreading within the social system? But to do this, we needed a kind of data that never previously existed. And we needed to painstakingly assemble this data. It took about 2 years of our life to get the grant, 2 years to build the data set, a year to get the statistical software to work, and another 6 months to get this visualization software to work to make this little video I'm about to show you right now. And this video was both the most exciting and the most depressing moment in my scientific career. And I first looked at this video in about 2006. Okay, so every dot's a person, every line represents a relationship. Here we only show non-genetic relationships. So I can't remember right now, but I think the gray lines are spousal connections, and the purple lines are, the gray lines are spousal connections, and the purple lines are friendship connections. And in a minute, I'm going to put this network into motion, and we're going to take daily cuts through the network for 32 years, every single day evaluating the network. And what you're going to see is, now, we're not going to observe the network every day, but on any given day, if something changes, a person is born or dies, you'll see dots appear and disappear. People gain or lose weight, you'll see dots get bigger and smaller, mostly bigger, and turn yellow, because that's the obesity epidemic that we're going to include in this time period. You're going to see people marry and divorce each other, and friend and defriend each other. This is the real kind of defriending, not the Facebook kind, like the old-fashioned face-to-face kind. So mostly you're going to see a sea of yellow in this network, which is the obesity epidemic. So the yellow dots are BMIs above 30, and the green dots are not. And I want you, as you're looking at this image, to tell me whether you see these waves of obesity or not. So here's the network. It's evolving. Here we are in 1974. In a minute, you're going to see this woman here. The red perimeter dots are women. The blue perimeter dots are men. She's going to gain a ton of weight. There she goes. And she's going to move to the middle of the network, right there. So now we're seeing the sea of yellow, because now we're on the upswing of the obesity epidemic in the United States. And it's going to stop in just a moment. And by the end, you're going to see some clusters of obese and non-obese individuals within the network. Now, be honest. Did you see this wave of obesity or not? No. We didn't see it. You want to watch it again? It's like a living, breathing thing, isn't it, these networks? We do this. We humans make these things. I think it's just unbelievable what we do. So we didn't see these waves. And we were so depressed. It took us like a whole day, James and I, before we figured out what the flaw in our thinking was. But usually in a group this large and this smart, there's often one person or two that can think of the reason. What was the flaw in our thinking? Why are these waves not apparent when you look at this image, this visualization? Any ideas? Well, the reason is that obesity is not a unicentric epidemic. Oh, there was a hand there?
Could it be like wave interference as friendships performed and drop?
Okay, that's a very good thought. It's a variant of that idea. It is wave interference, but it's not just because friendships are formed and dropped, because we take that into account. The reason is that obesity is not a unicentric epidemic, it's a multicentric epidemic. And the proper analogy is not a single hand dropping a single pebble on the surface, but a whole handful throwing a handful of rocks on the surface. So every rock falling, plink, 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 makes these waves, but the waves interfere with each other and you get a choppiness on the surface. Just like a fleet of boats entering a harbor, each one is leaving a wake, but the wakes interfere with each other and you don't see the pattern of any single boat, you get a choppy surface. So we needed other sorts of mathematical and statistical tools to find evidence for these waves. And incidentally, in the process of making these types of images, I began to see human social networks as living and breathing things. They have a kind of coherence to them. They heal when they're wounded. When someone dies, they anneal, they self-anneal. They have a memory. They have a kind of a movement. They have all kinds of properties that, to me, make me think of humans as being participants in a kind of superorganism like other species, as we'll talk over the next couple of lectures. So we began to use a variety of other techniques to unpack the existence of these spreading phenomena within the system. And now, one of the things we decided to do was take advantage of the directionality of friendship ties. Okay, so one possibility is that I say Dan is my friend, and Dan doesn't reciprocate the friendship, and so we're going to call that an ego-nominated friendship. This was my experience in high school. I thought all these people were my friends, and nobody knew who the hell I was. So I say Dan is my friend, and Dan does not know me. He might not be my friend anymore. We'll see afterwards. Another possibility is that Dan reciprocates the friendship, so we're mutual friends. And in this situation, we're mutual friends. So I say he's my friend, he says I'm his friend. And last, Dan says I'm his friend, and I have no idea who the hell he is. Okay? That's going to be an alter-nominated friendship. So you got it? There are three categories: ego-nominated, mutual, and alter-nominated. Now, in which of those three categories do you think that Dan's weight gain is going to be most likely to cause my weight gain? Mutual. Very good. We know and respect each other. We're paying a lot of attention to each other. Which next? Ego-nominated. Exactly. I'm paying attention to him. And last, if at all, alter-nominated friendship. Now, the reason this is important is that if the McDonald's opens up nearby and is making us both gain weight at the same time, the McDonald's doesn't care whether I nominate Dan or he nominates me. So if we see this kind of graded pattern according to the directionality of the friendship, it provides what's known in econometrics as an identification strategy. It helps us exclude the possibility of some kind of contextual or confounding effect to begin to unpack what's happening. And in fact, that's exactly what we found. We found that if an ego-perceived friend became obese in any given time interval, it increased the ego's probability of becoming obese by about 50 or 70%. If it was a mutual friend, it was almost 200% increase in the odds, and if it was an alter-perceived friend, there was no effect. We found that same-sex friends affect each other, but opposite-sex friends do not. So men gain weight when their male friends gain weight, but not when their female friends gain weight, and women gain weight when their female friends gain weight, but not when their male friends gain weight. We also found an effect between spouses and siblings. We found a slight hint of an effect in same-sex versus opposite-sex siblings. We found no effect of immediate residential neighbors. And we found an effect of coworkers, but only if individuals worked in a small workplace. So there seems to be some kind of social process that underlies this here. Some kind of esteem is important. I have to know and respect Dan for his actions or behaviors to affect me. I'm not affected by any old person to whom I don't have a real social connection. And as I already hinted, this directional data is important because it suggests that confounding by unobserved contextual factors is not a source of the relationship. Plus, the effect is gendered among friends, spouses, and siblings, further supporting the social nature of the effect at hand. Now, what might be the mechanism of spread? Well, one possibility is that I'm the ego, Dan's the alter. The alter's appearance or behavior could change the ego's behavior. So here the idea is that Dan says, let's go have muffins and beer. It's a terrible combination, but he's my friend and he suggested it. So I start adopting the muffins and beer diet. And as a result of that, I start to gain weight. The second possibility is that the alter's appearance or behavior changes ego's expectations or perceptions of norms. Here what happens is that Vegas suggests, oh, let's go, Vegas starts gaining weight, and that changes my ideas about what an acceptable body size is. I say, oh, I reset my ideas about what it means to be thin, and then I pass along that normative idea to the next person down the chain. And we found evidence for both of these phenomena in our analyses. Now, headline writers had a field day when we published this paper in 2007. For example, in the New York Times, the headline was, "Are you packing it on? Blame your friends." But what was very interesting is that the British newspapers reporting on the same result had the following headline, "Are your friends gaining weight? Perhaps you are to blame." So I think it's a very interesting contrast between American and British perceptions of themselves and of their social life. Now, I want to be very clear, of course, that we do not think that our work could or should be used to justify any sort of prejudice. And after this paper was published, I think James and I had 2,000 emails and a couple of death threats within the first week. I'm not kidding. Within the first week, because people thought that the overweight are already discriminated against in our society, and now here we were providing additional ammunition to individuals who wanted to stigmatize individuals who are overweight. But actually, if anything, our work was showing that norms were changing about overweight, that actually was becoming more acceptable, not less acceptable. Now, from a public health point of view, I've already gone on record as saying that I think that's not a good thing, but I certainly don't think it's good to discriminate or have prejudicial attitudes about individuals. Anyway, we started, after having done this, to explore all sorts of other phenomena. For example, we began to look at smoking, which has been decreasing and not increasing in recent decades. The prevalence of smoking, as we saw a few lectures ago, has declined from about 45% to 21% over the past 4 decades. Nevertheless, there are about 45 million smokers in our society, and it still remains the leading preventable cause of death, with nearly 500,000 Americans dying every year of smoking. And once again, we map the network. Every dot's a person, and the lines represent different sorts of relationships. Now we make the dot size proportional to how many cigarettes people smoke. And we color the dots yellow if you smoke 1 or more cigarettes. And if you look in 1971, you see that most people are smokers, and they're sort of uniformly distributed everywhere within the social fabric. But fast forward to 2001, and you see that people have mostly quit. And if you do a kind of visual and ultimately mathematical analysis of the network, you see, for example, zooming in on this region, that the smokers seem to occupy structurally peripheral portions of the network. It's like they've been pushed to the social margins. Individuals who remain smokers are now structurally at the edges of the network. An analysis similar to those that we did for obesity showed that on average, these clusters spread to 3 degrees of separation. And both clusters of smokers and non-smokers clustered to this extent. Moreover, additional analyses revealed the following. Now, on the left, that just mathematically firms up what I just said. Here we have the exam number. These occur every 4 years or so over the follow-up period. And here on the y-axis we have, so this is time. And on the y-axis we have something known as the eigenvector centrality, which is a way of measuring how central nodes are in the network. It's the similar math to what Google uses in its PageRank algorithm to identify the most central and relevant pages on the web. And what we find is that the non-smokers, their centrality within the system remains roughly constant across time, whereas firming up the visual impression I just gave you, the smokers become progressively less central. But on the right-hand panel, it shows you something else. On the x-axis, again, is time, and on the y-axis is the mean smoking cluster size. And what this shows is that if the smokers had been quitting at random, 45% to 20%, sort of uniformly quitting at random within the social fabric, the cluster size would have declined as shown by the red line in a random quitting process. But that's not what we find. What we find is that the observed cluster size remains constant across time. So how can that be? How can the cluster size of smokers be constant, but there be many fewer smokers as time goes by? Any thoughts? Yeah.
Smokers become tighter with other smokers and isolated from non-smokers.
That's a good idea, and actually that is what happens as a result of a causal process. What's the causal process that underlies that? Yeah?
Smoking has become socially unacceptable, and there's a lot of structural norms against it, such as rules in restaurants and things like that. So it's a lot harder for people to smoke, and so you would have to hang out with non-smokers. Smokers would have to hang out with smokers because it's in the smoking part of the restaurant, things like that.
Okay, so that's a variant on what he just said, but what's happening that underlies this increasing clustering of non-smokers and smokers? Yeah? Exactly. what happens is whole interconnected groups of smokers quit smoking at the same time, like a flock of birds changing direction, okay? So what's happening is clusters of people quit smoking, drop out of the system at the same time. And it's the difference. Imagine if I told you to lie on your back and look up at the heavens on a spring day. And I say to you, okay, every minute, 10% of the stars in the heavens are going to blink off. In one scenario, they blink off randomly across the heavens. And in another scenario, constellations turn off one at a time. One constellation, then another, then another. That's what human beings are doing. Interconnected groups of people who don't necessarily know each other roughly simultaneously evince a shift in norms, and they quit smoking like a flock of birds changing direction. Well, eventually we began to look at other sorts of things. For example, an analysis similar to those that we did for obesity showed that the same thing happens with smoking. We began to look like things like, banana eating, for example. So here we have yellow dots are banana eaters, red dots are non-banana eaters, and here you can see a cluster of banana eaters and non-banana eaters living very peacefully next to each other within the network. And because we were interested in some of the candidate mechanisms, maybe it's the muffins and beer spreading, we can try to begin to unpack that and see if that's what's happening. And we also started to look at other sorts of phenomena, such as the spread of emotions. Now, when human beings have emotions, we don't just experience the emotions, we show them. Why? Why do we show our emotions like fear or disgust? Any ideas? Yeah?
It's a way to convey, it's a lot better conveying mechanism than words are.
Yeah, so emotions can be a very efficient form of communication, in fact. But in the case of fear and disgust, actually these emotional expressions on our face evolve originally to affect our ability to take in sensory inputs from the environment. So the fearful individuals, their eyes widen to let in more light. Their mouth partens, their nares flare so they can smell and take in more air so they can smell the tiger that's about to attack them. And in disgust, you do the opposite. You squinch down your eyes, you contort your face in a way that prevents the intake of obnoxious stimuli. So it's not hard to construct an argument for why we would have evolved to experience emotions like fear or disgust, for example, or anger or happiness. But not only do we experience these emotions like anger and happiness, which are less connected to facial expressions, but also we show them. And not only do I show them, but you can read them. And not only do you read my emotion, but you copy it. Emotional contagion, you see, would be to be a deeply rooted part of emotional experience. So this emotional contagion, you see, for me, highlights the fact that emotions are not just about individual experience, but also about collective experience, reflecting in part a kind of communication function that we just alluded to. So this function of emotions suggests that whatever other advantages they offer, they also are a primitive form of communication. Now, we're accustomed to thinking about emotional contagion as fleeting and involving just a pair of people. And when I gave a talk about this research a few years ago in New York City, I said, when you're on the subway and the person across the car from you smiles at you and you just instinctively smile back, and they said, we don't do that in New York City. And I said, well, everywhere else in the world, that's normal human behavior. And of course, emotional contagion can be broader still, such as in the punctuated collective expression of anger in the form of riots. But we wondered whether emotions might spread beyond pairs of people, and might they do so in a more sustained way than riots? Could there be a kind of a quiet riot? Could there be a kind of below-the-surface emotional stampede rippling below the social fabric, coming to affect us all? Maybe emotions spread beyond pairs of people in a more sustained fashion all the time. In fact, maybe emotions have a collective existence and not just an individual existence. So we made what I think is the first network map, what I know is the first network map of human emotions. Here every dot is a person, the square dots are men, and the round dots are women. Now we color the dots according to how happy they are. The yellow dots are happy people, the blue dots are sad people, and the green dots are people in between. And if you look at this image, you can again observe that there appear to be clusters of unhappy and happy people within the system. And these clusters also spread to 3 degrees of separation. In addition, you might be able to see that the unhappy people are more likely to be located on the periphery of the network. And actually, James and I could not resist, because much of our research agenda was driven by our experiences in high school. When James and I, who were very nerdy, when we were in high school, we would have all these arguments with our mothers we would say, if I could just be more popular, Mom, then I'd be happy. And our mom said to us, no, if you were happy, you'd become more popular. So 40 years later, and many millions of dollars and multiple graduate degrees, we were finally able to test this proposition that our mothers had made to us. Because the question is, what makes you happy? Is it being in the middle of the network that increases the probability of being happy, or is it being happy that moves you to the middle of a network followed across time? And after we analyzed the data, we found that actually, although both are true, rarely on this occasion we were right and our mothers were wrong. Actually, being popular has a bigger effect on increasing your happiness than being happy has on increasing your popularity, moving you within the network. Now, to get around some of the potential problems with drawing conclusions from observational data, which is the kind of using kind of naturally occurring data, all the work I've shown you so far has been observational, and to begin to explore some of the deeper functions of networks suggested by this contagion of emotions, we began to do some experiments, creating artificial networks to study. And this is a paper we published a couple of years ago now. In this paper, we took advantage of data of Swiss college students who were strangers to each other. And groups of students who were strangers to each other were brought into a laboratory, and they were randomly assigned into groups of 4. And they were each given a little bit of money to play with. They could contribute money to the collective of 4 individuals, and if they contributed that money, the researcher would multiply the money. Everyone would benefit, but the individual paid a price. So it's a public goods game, and it's a classic trade-off between the individual well-being and the collective well-being. From the point of view of any given student, the best thing to do is to defect, not to cooperate, not to give any money, and hope everyone else contributes, and you get the benefit from others' cooperation. But of course, if everyone defects, then the whole group suffers. So it's a public goods game. What happens in this situation, however, is that every so often a bell would ring, and the students would be separated and randomly assigned to play with new strangers. Then a bell would ring, and they'd be randomly assigned to play with new strangers, and so forth and so on for 6 rounds of the game. So at the first round of the game, A would play with B, C, and D. Then A would play with E, I, and M, who had previously played with these people. And then A would play with J, S, and V, and so forth. And what we recognized is that we could use this type of an artificial arrangement to reconstruct networks of interactions, such that we could test the proposition, not that if I am kind to Lucy, will she reciprocate the kindness in a kind of reciprocal altruism that's very interesting, but not as hard to explain. Rather, we want to see if I'm kind to Lucy, does she then pay it forward and she's kind to you? And then when she's kind to you, you're kind to her. And there's a kind of spreading process within the network. And in fact, that's exactly what we were able to find. What we found is that if Eleni was kind to Lucas in period 1, Lucas was kind to Erica in period 2, Erica was kind to Jay in period 3, and Jay was kind to Brecken in period 4. And this is one of the most amazing results that I've had in my lab in the last 5 years. What I've just told you is that how Jay treats Brecken depends on how Eleni treated Lucas, even though neither Jay nor Brecken ever interacted with Eleni or Lucas. How these two people treat each other depends on how these two people, far removed in the network, treat each other. If they're kind to each other, that kindness will spread within the system. And this geodesic spread across degrees of separation within the system is different than the persistence across time, whereby if Eleni is kind to Lucas, Lucas learns to be kind, then he goes on to be kind to Erica in period 2, and Lysander in period 3, and Vemi in period 4, and Sebastian in period 5, and then Nicholas in period 6. And in fact, when all the downstream ripples are added back together, for every extra dollar that Eleni gives to Lucas, the network functions as a kind of matching grant, doubling the downstream contributions of this initial donation that is given. So pay it forward is real. So things spread in networks, and this has been shown for a variety of non-obvious phenomena. For obesity, smoking, I've shown you some results, drinking and drug abuse behavior, tidiness behavior in dorm rooms, for example, happiness, loneliness, depression, and altruism, I just showed you some results, divorce, voting behavior. There was a beautiful experiment that was just done by James using Facebook 2 years ago. 61 million people were randomly assigned to an intervention, the largest experiment ever done, showing that if you prompt people to vote, voting behavior will spread within the network. Tastes behavior, and as we'll discuss next time, and also ideas. And this 3 degrees is just a rule of thumb. Not everything is 3 degrees. Some are 2, some are 4. The thing I want to emphasize is that it's more than 1. When we affect the people around us, they go on to affect still other people. And because of the exponential growth in the number of people as you move out a geodesic distance from me, I can come to have a huge effect on other people for any change that I make in my life. And I should emphasize that not everything spreads, and not everything that spreads by the same mechanism. So germs spread differently than ideas, which spread differently than emotions, which spread differently than money, which spread differently than behaviors. Just because we use the word spread doesn't mean we further understood the mechanism by which these things spread. And I should emphasize that both good and bad things can spread. Violence can spread. Ebola can spread. Unhappiness can spread. But so can love and kindness, and ideas can spread. And in fact, a key idea, a high-level, very important idea, is that networks magnify whatever they are seeded with. Networks magnify whatever they are seeded with. But they must be seeded. There has to be a hand dropping rocks, otherwise you don't get the waves. Something outside the system has to come into the system to start it, and then the network takes over and magnifies an effect that otherwise would have been present. So it's not our contention that the social networks explain the obesity epidemic. Other sorts of factors, like we discussed a few lectures ago, the declining real price of food, the marketing of food, the suburbanization of America, the kind of move to a sedentary lifestyle, all of those things are playing a role in the obesity epidemic, but the network takes that impetus and magnifies it, makes it even bigger than it otherwise would have been. And as I'll be discussing over the next couple of lectures, this actually, in my judgment, is one of the deep evolutionary functions of human social networks. One of the reasons we assemble ourselves into these ant colony type elaborate Baroque structures is precisely to achieve this magnification function in ways that I'll make clear. So we have a number of ideas for why it might be to 3 degrees of separation. Why 3? One possibility is just simple decay. There's friction in the system. Like if you drop a pebble in the ocean, the waves don't cross the whole ocean. The water molecules have friction with each other. Eventually the energy dissipates. The amplitude of the wave declines as you move away from the drop point. Or if you're playing like the children's game of telephone, the fidelity in the message gets degraded. I whisper to you, you whisper to him, he whispers to her. After a while, it's gone. So simple decay. Another possibility is what we call the network instability idea. Here the idea is that you're connected to your friends, and those are stable connections. Maybe once every so often, one of your friends might leave town or no longer be your friend or die or something, and you lose that person or that connection. And at 2 degrees of separation, you're connected to people 2 degrees removed from you by virtue of 2 ties and 1 node. So now there's a lot more possibility that you'll lose that connection because you have more things that can fail. And at 3 degrees of separation, even more. So this is sort of like the electron shell model. As you move to higher and higher orbits, the shell becomes more and more diffuse. So right now, your friends are the same friends you had a year ago. But your friends' friends are not the same friends you had a year ago. There's this constant movement at this shell that's far away from you. You lose connection to those individuals because of the possibility of a tie breaking anywhere along the path. And as a result, the reason you can't affect people 4 degrees removed from you or be affected by them is that the people, when you send the message now to those people, by the time it gets there, they're gone. They're different people. We refer to this as the network instability model for why 3 degrees. And last, an argument which we'll be discussing more in the next few lectures is the evolutionary origin of these types of effects, having to do with the fact that we evolved to be in populations in which in our Pleistocene or in the ancestral past, there was no one more than 3 degrees of separation. We didn't evolve to be able to send signals or receive signals more than that far away. So this perspective on humans and on social systems that I'm introducing today has a number of implications. First, we begin to gain some insight into how the whole comes to be greater than the sum of its parts. In fact, I think it's the ties that make the difference between groups and networks. It's the ties that add value and that lie at the root of the emergence of additional properties within social systems. Second, this type of perspective, this network perspective, means that there can be new kinds of hierarchy in social systems that we've previously not paid much attention to. So we're used to thinking about who's black and who's white and who's rural and who's urban and who's rich and who's poor and all kinds of other ways we stratify our society. But previously, in the social sciences, we haven't paid as much attention, in my judgment, as we should to the way networks affect stratification or hierarchy. Which network are you a part of? Are you in the middle or on the edge of the system? Which subcomponent of the network, which network clique do you occupy? And these types of factors can also affect your prospects in life in a variety of ways. Third, this perspective sheds light on the importance of free will. Now, when our work came out originally, one of the ideas I think that it caused such a brouhaha was that people felt very threatened by it. They felt like somehow we were saying to them that you lack agency, that it's all about structure, that you can't determine your own destiny. We had in some way delivered a whack to free will. Because what I've been showing you today is that how big you are, what your body size is, whether you smoke, whether you're happy, how you treat others, whether you're kind, is significantly affected by things that are out of your control, by what's happening in people at some distance removed from you from the network. So in fact, what I've done today is I've taken away some of your free will. I've taken away some of your agency. I've shown you ways in which that's not the case. So people didn't like this. But our response to those people is that even as that work, because it's true, our work does show that, but even as it's showing that, it's also showing how not only you're affected by others, but how you affect others. So when you exercise free will and make a positive change in your life, it doesn't just affect you, it doesn't just affect your friends, but depending on the circumstances, it can affect dozens, hundreds, in some cases thousands of other people come to be affected by changes that you make. And fourth, overall, we think that there's a very deep and fundamental relationship between social networks and goodness. And in fact, overall, I think I've come to believe, and we'll be showing you, that we form social networks because the benefits of a connected life outweigh the costs. And this is another very important high-level idea. The benefits of a connected life outweigh the costs. Look, if I was always violent towards you, or gave you bad germs, or gave you misinformation, or made you miserably unhappy, you would cut the ties to me and the network would disintegrate. Therefore, the flow of good and desirable things like love and ideas and altruism and happiness is required to sustain and nourish the network and keep the ties intact. And similarly, those ties are required in order for all these things that we consider so wonderful and desirable about our society to exist and to endure. In fact, I think if we realized how valuable social networks are and what they are doing for us and what they can do, we'd be the better for it. Because I actually think that social networks are required for goodness to flourish. See you next time.